Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Hi Madbar Joshi. आज का question easy है? Yes, definitely it is a pattern based question. Okay, so guys, you can hit the like button and give me a +1 if everything is working fine. Then I can share my screen and we'll discuss the problem as well. Okay, so I hope that my screen is getting shared properly. And let us begin with the problem statement as well. So basically, let me remove all the code part. And in this particular problem, what we will be given is, will be given a particular value of n. Okay, and we have to find the total count of set bits from 1 to n. Okay, so one of the like very basic approaches, hi Rishit as well, right? So one of the very basic approaches is that if we have been given a number n and we have to count all the number of set bits from the number 1 till n, then what we can do is for every number we can try to count the set bits, right? For one I will count the number of set bits in it, for 2 I can count the number of set bits in it, for 3 I can count, and so on and so forth till n I can count, and then I can return the counter. Right, please write yes in the chat. But this will be a very brute force way to do it. Instead of that, what we can do is we need to observe a pattern kind of a thing in the problem. Okay, so in this case, let us say that we have something like let me write it. So let's say we have something like 0 0 0 and then 1, then we have something like 0 0, then we have 1 0. Okay, so let me write few numbers here, right? So how many total set bits are there? Can I see any pattern? Maybe I can say that if you can see here that the n value is 2. So here maybe I can say that at this particular position, how many set bits are there, right? So you will tell me that okay, at this particular point, n by 2 number of set bits are there, half, and at this point, at this particular place also, you can say that half of the bits are set, right? That is what you can observe. Okay, then after that, if I will move further and I will write for 3, so 0, uh, 0, then 1 1. So do I find any pattern for n is equal to 3? I don't think so, right? Because I cannot see any pattern. If I write n is equal to 4, so this will be 1. Okay, let me write it properly. So this will be 0, this will be 1, this will be 0, this will be 0. So I need to find a kind of pattern which can help me out. Okay, so please write pat in the chat. So still, if you will see, so for n is equal to 4, if you don't think about this guy, then half of the bits are set here and half of the bits are set here, right? That is what I can observe. So we still need to write for more, and we can see that for maybe for some kind of even number we are able to find some pattern, right? So if I will write for 5 and 6 as well, suppose I am writing 6, so if I am writing 5 here and then after that I write 6 here, right? So can we observe any pattern here, any pattern for every position? See, can I see that if the n value is 6, right? So you can observe that at this point half of the bits are set, right? Please write yes, 3 bits are set here. If n value is 6, half of the bits are set here. Maybe you can observe that half of the bits are set here. So maybe we might come to think of it that maybe for even numbers we have a pattern, right? So we need to like please write even in the chat. So we need to verify, do we have a pattern for even numbers or do we have a pattern for anything else, right? So then I will write for 7, I'm not going to have any pattern. For 8 I will check. So first of all I'll write 7, so 7 will be this, and when I'll write 8, so it will be something like this, right guys? Okay, then after if you will see for 8 also, how many bits are set at this place? 4 bits are set, half of the bits. Please write n by 2. How many bits are set at this place? Half of the bits, right? N by 2 number of bits. For how many bits are set here? N by 2 number of bits here. Please write yes in the chat. Do you agree with me on this point, guys? Everybody does agree? Yes, you do, right? But I need to check for 10 also. Let's see whether for 10 also the same thing applies or not. So if you will see here, first of all I'll write 9 and then I will write 10 here. All right, this is what I will write. Hi Vanchika Kapoor, very good evening as well. So see, in this case, now I have written 10. Okay, so let us see, do we have half bit set or not? So if you will see here, can I say that I'm having 1 2 3 4 5 bits set here, right? Okay, how many bits are set at this place? 1 2 3 4 5 bits are set here. Then how many bits are set here? 4 bits are set here, right? How many bits are set here? 3. So please write no in the chat. Is there any pattern? See, earlier I was thinking for the even numbers I'm having a pattern, but actually for even numbers I'm not having any pattern. I'm having the pattern only till the I'm not having a pattern for even numbers. So for what kind of numbers will I have a pattern? I will have a pattern for the closest power of 2. Okay, power of 2, please write power of 2. I will have a pattern for power of 2. So if you see till 8 now, if you observe till this point, if you observe till 8, okay, so if you see here till this point, how many bits are set at this place? 4 bits are set. Okay, till this point, how many bits are set? 4 bits are set. If you see till this point, how many bits are set? So again, you can say that 4 bits are set. So n by 2 number of bits are set. If you check till 8, and some bits are extra, that I will tell you further. But is this much part clear? That the close for the closest power of 2, the bits there is a pattern there. Is this part clear to everyone? Please write yes or no in the chat. Okay, is this part clear to everyone? Thanks a lot. Okay, so see now, let's say I will write it till 13, somewhere till 13 if I'll write it. Okay, so if you see here, 1 0 1 1, okay, this will be I think 11. Then let me just think, did I wrote something incorrectly or what? 8, this is 9, this is 10, this is I think 11. Then how do I write it? 12. 1, okay, 1 0 0, I think, if I'm not wrong. That is how I can write 12. And how do I write 13 here? 1 1 0 1. Am I correct, guys? Please write yes or no. Help me out with this. Okay, so is that part clear till now? Right, if I have my having n is equal to 13, right? So you can observe that till the power of 2 I'm having a pattern. Okay, so till 8 I am going to have a pattern. So I'm going to find the closest power of 2. So you can say that till 8 I'm having a pattern. So where is 8? 1 2 3 4 5 6 7 8. Okay, so if till this place I'm having a pattern, right, that is what we can observe. Because you can see that till this place, how many number of set bits do I have? So I'm just bifurcating this part. Okay, so you can see here in this part how many bits are set. So you can directly see that 4 bits are set here, then 4 bits are set here, 4 bits are set here. At how many places the bit are set? Can anybody tell me? Which power of 8 is 2? 2 is not 8 is what? 8 is nothing but 2 to the power 3. Please write 3 in the chat. So please write 3 in the chat. For 3 positions I'm having this guy, right? For this is first position, second position, and third position. So for 3 positions I can see that n by 2 number of bits are set. Is this part clear to everyone? Please write yes or no in the chat. Is it pretty much clear till now, right? So if n value is something like 3, then for 3 position I'm having the bit as set. Okay, so in this case, what is the closest power of 2? So this is 2 to the power 3. So if I name it in terms of p, so this is nothing but 2 to the power p. Okay, so if p value, if this is 2 if this can be said as 2 to the power p, where p value is nothing but 3, so can I say that for p positions, please write p in the chat. For p positions I can find this pattern for 1 position, 2 position, 3 position. So at one position I'm having how many bits, if you will see. So in this particular case, if you could observe here, right, so how many bits I'm having a set for one position? I'm having how many bits as set? 2 to the power p divided by 2, right? That is nothing but 8 divided by 2, that is 4, right? 8 by 2 is nothing but 4 here. So closest power of 2 divided by 2, that much bits I'm having a set. Okay, so for p number of positions, how many bits are set? 2 to the power p divided by 2 into p. Is this part clear to everyone till now? Please let me know. Yes or no, guys? Is it pretty much clear to everyone? I think so that this much part is clear, right? So this is one point, right? So if I will observe here, so for this particular case, you can see that I'm having what 3 into 4, that is 3 into 8 by 2. Okay, so 3 into 8 by 2. Let me write it as this thing. So if I if I write it like this, let's say 3 into 2 to the power 3 divided by 2, right? So that is going to be nothing but p plus if I'm having p as the closest power of 2, so 2 to the power p divided by 2, this much part. Okay, so let me just do one thing. Let me just highlight this part. Yeah, so this is the yellow part. So what I will do is now I'll write it using yellow color only. Just give me a second. So this will be 3 into this will be 3 into 2 to the power 3 divided by 2. So in general, it will be p into 2 to the power p divided by 2. Is this part clear to everyone? Please write yes or no in the chat. Is this much part clear? Now, if you will see one more thing, right? So this much point I think is clear. Now, if you will see one more thing, again, I have written it using the same color. Sorry for that. So yeah, just give me a second. So it is nothing but 3 into 2 to the power 3 divided by 2, that is nothing but p into 2 to the power p divided by 2, right? This is the point. Now another thing that I want you to observe is, if you observe this some remaining parts, right? So if you can see here on the right side, this white part, please write w in the chat. Okay, so how many bits are I'm having here? If you will see here, how many bits I'm having here, because I will count this also, right? Then I will see rest of the rest of the part, I will see that there is a pattern existing. Okay, so if you will see in this white portion, how many bits are set here? Can anybody tell me? If you will see 1 2 3 4 5 6. Okay, so these 6 bits are extra. Please write yes in the chat. Is this part clear, that 6 bits are set here, right? This part is clear. So 6 extra bits I need to count. So for that, if I'm having n as 13, so if I do 13 minus 8, I will get 5 plus 1. If I do, then I will get what? Then I will get this value, that is 6 extra bits on the left side, right? On the left side. Is this clear? Right. So I have to do what? N minus 2 to the power p plus 1. Is this part clear? N minus 2 to the power p plus 1. Yes, thanks a lot for this confirmation that everyone is clear, right? Is this clear to you, Matbar, as well? Right. So in this case, what I have to do is plus I have to write this thing, that the white bits that are set will be nothing but n minus okay, so yeah, if I'm right, sorry, here in this case, if I have to write this here, so it will be nothing but 13 minus 13 minus what, 2 to the power 3 plus 1, right? So if I have to write the general formula, so it is nothing but n minus 2 to the power p plus 1, right? Is this part clear? Right, so that's how I've counted the yellow part and the white part. Okay, now comes the idea, like what is the idea for this much part? Okay, what are the number of set bits in this part? Okay, is this much part clear till now? Now what are the total number of set bits in this part? I will like to highlight it with this color. Just give me a second, let me just highlight the white part differently. And yeah, so if you will see, now let's highlight this pink part. Okay, so what is the number of set bits in this part? If you see, can I say that this is actually this is nothing but 001. So this is 1, this is 010, so this is nothing but 2. If you see this pattern, right, please write pat in the chat. If you see, this is nothing but 3. If you see, this is nothing but what, 4. If you see, this is nothing but 5, right? So can I say that I can redefine this question, and I can say, I can ask you to count in this section I can say that this is a sub problem, right? This is a smaller problem. Please write small in the chat. This is a small problem because in this I have to count the number of, okay, number of set bits, right, from 1 to 5, right? From 1 to 5. Please write small in the chat. Okay, this is a small problem, right? Same work, this is the same work that I have to do, and it's a small problem about the same idea. Is this part clear, guys? Yes or no? Right, this is a smaller part that I have to do again, right? This is a sub problem or the same problem that I have to deal with, right? So how do I get this 5? Because if you see, so I have to if you see this rest of the part, right, this particular part, so that is having the number of set bits, that is nothing but the number of set bits that are there from 1 to 5. Okay, so I can say that if I'm having the number n value as 13, right? So if I had the n value as 13 here, right, you can see originally if I had the n value as 13, so I can say that if I do 13 minus 2 to the power 3, that is closest power of 2, 8. So that is 5. So I have to calculate the count. I have to recursively call the count function. So I can say that I have to call the count function again, and in that I have to pass n minus 2 to the power p. Is this point clear to all of you guys or not? Right. So what I need to do is I need to count, I need to call the same function again, because same thing has to be done, because it has to count the number of set bits from 1 till 5. So indirectly it has to count for n minus 2 to the power p, right? So that is why here what I will write is plus count of 13 minus 8, so that is 5. So this will count the set bits from 1 to 5. Is this part clear to everyone? Right, so that is the general formula. Please write formula in the chat or F in the chat if this part is clear to everyone, and if it is clear, then you can make sure to hit the like button as well, guys. Okay, is this particular part clear to everyone? I have tried to explain it as easily as possible, right? Is this part clear to everyone? Please write yes, hit the like button as well, guys. Right. So again, summarizing it for you, the pattern was there for powers of 2. So here for n is equal to 13, I can calculate this much part. So one position is there, two position, three position. I'm having four bits. So I can say that for n is equal to 8, I'm having a pattern. So the number of set bits would be nothing but the number of positions, that is 3 into 2 to the power 3 divided by 2, because the closest power is 3. So if I assume that it as p, so p into 2 to the power p divided by 2, that is nothing but 3 places, and 8 divided by 2 is nothing but 4. So 12 bits will be set there, right? Then after that the white part, so that is nothing but 13 minus 8 plus 1. So total 6 bits were set. So that is how I can count it. So that will be nothing but n minus 2 to the power p plus 1. Okay, that is the thing. And after that the remaining part that I highlighted here, that is this particular part, the purple the pink part here, right? So in this particular pink part, I can observe that this is nothing but counting the total number of set bits from 1 till 5. So that is nothing but I am calling the count function for n minus 2 to the power p. Okay, so basically that is nothing but 13 minus 8. That is nothing but this part. Is this part clear to everyone? Okay, are you clear with this part, guys? Right. So yeah, that is what we have to do here. So we have to first of all find p. Is this question pretty much clear to everyone or not? Please write yes or no, guys. Okay, so that is how I've explained this question. I'm not sure whether you were aware about this particular pattern or not earlier. Right. So in this case, what I have to do is, first of all, maybe let's say I can declare a long int p that will be the closest power of 2. Okay. Initially, I will mark it as 0, and there will be a base case in this recursive function also, now, because the n value will keep on decreasing. So please write base case in the chat. So when suppose that n is equal to 0, then you will return what? Then you will return 0 itself, right? Because that is what you need to return. Then you have the initial p value which is marked as 0. So I will check that while the number is greater equal to power of 2 comma p. Okay, so I'll check if the n value is greater equal to 2 to the power p, then I'll keep on doing p plus plus. Now what do I mean by that? So let's say n value was 13. Okay, and the p value is initially starts from 0. So I check, is 2 to the power like, is n greater equal to 2 to the power p? That is what I keep on checking, and if it is, then I keep on doing p plus plus. So I check, is 13 greater equal to 2 to the power 0? Yes, so I will do p plus plus, so p becomes 1. Then after that, is 13 greater equal to 2 to the power 1? Yes, so I do p is equal to 2. Then after that, is 13 greater equal to 2 to the power 2? Yes, so I will do p is equal to 3. Then 13 is greater equal to 2 to the power 3. Yes, so in that case, again I have to do a p plus plus. So 13, is 13 greater equal to 2 to the power 4? No, so that is when I will break. So at p is equal to 4, if I'm breaking, but actually I want the p value as 3. So after coming out of the loop, I will have to do p minus minus. Is this part clear to everyone? Please write yes or no in the chat. Please write yes or no in the chat. Okay, is this part clear? Right. So that is why I'm doing a p minus minus, because since my p reaches to 4, but I needed 3, so that is why I'm doing this, right? Then I can say that long int, if I have to find the result, so that will be nothing but what, as I already said, p positions, p into power of 2 comma p. Okay, that is that divided by 2 plus what, plus this will be nothing but, as I said, the rest of the 1 bits that were there. So n minus power of 2 comma p, right, plus 1, right? And then again adding what, again calling the same function, to count bits function I'm calling. And in this function I have to pass what, n minus power of 2 comma p, and then I have, yeah, I have to just pass this part. So is this much point clear to everyone or not? Please tell me, guys. Is this part clear? And then ultimately I think I can just return the result. So is this part clear? P into 2 to the power p, as I've already explained through this diagram, right? You can see here. So the yellow part that was common, so closest power of 2. So that much sum will be p into 2, that much number of set bits will be p into 2 to the power p plus, sorry, divided by 2. Rest of the 1 bits that were in the white part, that will be nothing but n minus 2 to the power p plus 1. That is total 6 bits were here. So 13 minus 8 plus 1 it was, right? So it was nothing but n minus 2 to the power p plus 1. And the rest of the pink part that I'm having, it is nothing but counting the bits from 1 to 5. So again I have to call the recursive function. Okay, so same function again, that's something but n minus 13 minus 8, that will be 5. So that is how I'm calling it. Is this observation clear to everyone? I hope that it is, right? All right. Please tell me, guys. I hope that this part is pretty much clear to everyone. Now let's try and submit this code as well and see if it can get accepted. Okay. So yeah, you can see that it gets accepted, and the main complexity part is for which part? The main complexity that I'm getting, it is for the while loop. Okay, so basically it's log n. You can say that the time complexity of my loop is log n. Yeah, it will be able to handle the n is equal to 1 h case also. Yeah, my formula would be able to handle that also, because if you will see here now, if you will see, if n is equal to 1, then the formula will still be able to handle, because the closest power of 2 will be 0. So it will be p into 2 to the power p divided by 2, plus what it was, n minus 2 to the power p plus 1, plus count function will be called for n minus 2 to the power p. Okay, so in this case what will happen now? P value, the closest power of 2 will be 0, p is equal to 0. So then what will happen? This whole expression will become 0 plus 1 minus 1 plus 1, and plus the count function will be called for n minus 2 to the, n 1 minus 2 to the power 0, right? So that will be nothing but 0 itself. So I'm calling for 0, so I'll get a 0 here. So in this part you can see 0 plus 1 plus 0, so I'll get 1 here. So that is how it will be covered for 1 also, Rishit. Okay, is this part clear to everyone? Please write yes or no in the chat, guys, and let me know if it is clear or not. I hope that everyone is now clear with this question. Did you enjoy this question, everyone? Like earlier, you were more clear, or now more you are more clear with this one? Please tell me, because I think that you had already done this question, but was it clear this much? Would you have explained in the interview like this, or not? That is not. I'm. That is one thing that I just wanted to ask all of you. Okay. If it is more clear now, then you can give me a plus one if this approach is clear, right? So basically the main complexity is for the while loop that I have written. Okay, so it will basically be taking the main complexity, that is nothing but log n complexity, right, for finding the closest power of 2. So overall complexity will be kind of logarithmic in nature. Can you explain the time complexity to very video? I think it is not better for understanding. It is not there for better understanding. So as I said, it is log, because it is log n to the base 2, because ultimately every time you are going to decrease the value. So but this while loop is the main thing. This part is just constant operation kind of thing, right? Just adding the result. So here the while loop is the main thing, and it will run for log n times, right? Because I'm finding the closest power of 2. So the complexity will be log n, and for the rest of the functions you will say that it will also be called, but the n value will become smaller. So overall the main like it might be log capital N plus log n2 plus log n3 for various recursive calls, but overall it will be log n only, because the biggest value of n initially that is there, that will be the main factor deciding. So that is how it will be working. Okay, so it will be log in nature. Is it clear? Because when you use a basically I'm finding the closest power of 2, so this will take log n time, because it is running 3 times. No? You can observe almost 3 times it is running for 13. So it's kind of log only. Okay, Utkarsh Sharma. Is it clear? Right. So this was the problem of the day that we were required to discuss. Okay, it was a very good problem, and to be honest, this question count total number of set bits. It has been previously asked in Microsoft, Amazon, and I think Adobe as well. So it has been asked in quite some companies, although it was not mentioned here. But this problem has been asked in companies also. So if I'll just share my screen. So again, as I'm saying, so just give me a second. Right. So this question has been asked in some companies also, right? So these companies are nothing but Microsoft. Okay. Adobe has also asked this question, I think, and Amazon has also asked this question, and maybe many other might have also asked. So make sure to practice such questions. That is why I always say that you should try and solve the GFG problem of the day as much as possible. Okay. So with that being said, thanks a lot for joining for today, everyone. Thanks a lot, Utkarsh. Thanks a lot, Madhba. Thanks a lot, Vanshika. Thanks a lot, Rishit, as well. I will see you with another problem of the day tomorrow. Till then, good night. Take care. And guys, keep coding, keep hustling hard, keep upskilling your level. And thank you everyone for joining and showing so much patience. Thanks a lot, guys.